All right, welcome back to the final module in class 1 of my Intro to Programming class, Intro to Python. If you're enjoying these videos, go ahead and please do me a favor and subscribe and like the video so that way it gets spread across and I can start doing more of these videos. Also in the comments, if you ever have any suggestions of video series you'd like to see me do, um, I'm definitely interested in doing these types of videos in the future. So if there's a series on, I don't know, networking or ethical hacking or whatever topics that you're interested in, go ahead and let me know and I'll see if I have the spare cycles and I'll do a 10 class series on any of those topics as well. So with that, go ahead and please like and subscribe these videos and share them with your friends. All right, with that, let's go ahead and start talking about arithmetic and logical operators in Python. Getting our hands dirty now with actual useful code, we're going to talk about different operators. Now, our last code we talked about the different data types that we can store, strings, integers, floats. Now let's talk about the specific ones we can do with numbers. We have integers and floating point numbers that we can do all these arithmetic operators on. Then we have logical operators that work on Boolean expressions. So they can take integers in or floating point numbers in, and they're going to convert it to a Boolean data type. So either a true or a false. And then we'll end doing some more logical type operators. These are going to be comparison operators that are going to yield back and give us Boolean results as well. So with that, let's go ahead and talk about other data types that we can do, other operators that we can do. Go back to our friendly website called the W3 Schools for Python, and we can go down to data types. Where's I'm looking for? I'm looking for operators. We're going to scroll down to the operators section, and you'll notice that my class is just a subset of all the different operators that are out there, right? So in Python in its totality has arithmetic, assignment, comparison, logical, identity, membership, and bitwise. So a lot more operators than we're going to cover. However, in my 20 plus years of software development, I've seen these other ones, but not nearly as often. And actually, we will talk about identity ones, and we'll use those in a future, but those are more for advanced data structures. So today, we're going to focus on 90% solution. If you want the 100% solution, please come to this website and learn about the different operators. And you can also hit the try it button, right? So you can pull up their emulator and see how the code works, right? Doing simple arithmetic. And you'll see the result. So I can't stress enough the need for you guys to just start practicing, seeing how this stuff works, making mistakes, because if you make like a mistake like, hey, let's use capital Y, and you don't realize that you did a capital there and you try to run it, well, actually, let's do it the other way around. Let's do this as a lowercase, I'll move this as a capital. And you'll see that we'll actually end up getting an error because the variable Y doesn't exist, right? So making errors will make you a better software developer. So come and practice with the different operators. But for the time being, let's focus on the standard set of arithmetic operators. And we can do these operators on integers. So I could do something like print, we'll say 3 plus 99, I don't know, something like that. And just simple arithmetic lets us do math in here. I could string a whole bunch of these together. Plus, I don't know, 50, whatever, oops. And so I can have a whole bunch of these operators in one statement. Remember, a statement is one line of code, so this whole print statement is one line of code. I can use variables, so I can say age equal to, I don't know, we'll say 55, and we'll say my age, and we'll say your age, and these are just made up numbers, so don't get insulted if I make you too old or too young or anything like that. We're just doing it as an example, so we're going to say, are we together, oops, Control Z that, how old are we together, right? Hey, we're 80 together, right? 80 years young. So that's how we can do simple math. We can use variables like we learned last module, or we can use the numbers themselves. but it's simple to do addition. I just use the plus sign. Kind of intuitive math, right? I can also do the subtraction. I can do my age minus your age, and I'll get 30. What if I did your age minus my age? What do you think is going to happen there? Yeah, we're going to get minus 30, right? So we can do minus numbers as well. So Python goes from pretty much minus anything to plus anything. Okay, so that's subtraction. I can, again, do random subtraction with variables. I can do it with integers. I can combine addition and subtraction. So your age minus my age was minus 30. Then I add plus 43, so I get 13 as the result. So I can combine these things just like I can in math. I can do multiplication. Hey, let's multiply the minus 30 times 43, and we'll get some gigantic negative number, right? 2,340. Now, we've noticed that this number doesn't have a decimal place, and that's because I've given it two integers. What if we do fractions of age? Maybe I'm 55.25 and you're 55.5. What do I get there? You see how I get now? I get a decimal number. What data type is decimal? Do you guys remember that data type? And we'll go ahead and print this exact same statement here. And we'll go ahead and run that. You'll notice that it's of type float, which means it can be any number from minus infinity to infinity, including decimal places. But we lose precision and speed. Now, one thing I want to point out with this is what I did here. I did a print statement, then I open and I close the parentheses for the print statement. So that contains what gets passed in to this, what we call print method. So the print method is doing something for us, and what it's doing is it's writing something out to the screen. So the start parentheses and the end parentheses are containing everything that's going to get pushed into that print method. What gets put into that print method here is this type, and that type goes from this whole statement. So what's getting passed to the print statement is this type statement. And then what's contained in this type is everything that's in this parentheses to this inside parentheses. So these three, or two variables and a number, are getting passed into the type. But what happens is before it gets passed into the type, it actually does the math for us. So Python starts the inner part of it, says, okay, your age minus my age is minus 30. Minus 30 times 43 is minus 2350.25, or whatever, that number. And that number is what gets passed into type. Then type says, okay, well, it has a decimal place, therefore it's of type float. So I'm going to print out float when I hit the print statement. So I just wanted to give you how that unwraps, because you see me type it a couple of times. I just wanted you to understand what's going on and how it functions. So it starts at the inner part, does the math. That math gives us a number. That number gets put into our type method. The type method replies back with the type of float. That float is what gets printed out. I hope that makes sense. All right, so let's go back to being integer. And we'll go ahead and run. Actually, I'll copy and paste this. And I'll leave these as 0.55 and 0.25 just for, because I'm gonna make this Python notebook available for you all to download on the YouTube site as well. So if you want to access this file, you can kind of play around with it as well. All right, so this is now integer, and when I run this statement, you'll see I get type int. So bottom line is, if I start with integers and I do addition, subtraction, multiplication. In fact, let's add an addition here. We'll do 12 plus. So now I've got addition, subtraction, and multiplication, and I'm going to go ahead and do that in here as well. 12 plus And you'll see that I get still of type int because 12 is an int, your age is an int, my age is an int, and 43 is an integer. What if I make one of these a floating point number? What do you think is going to happen if I make this one 43.0? My result, oops, I forgot to put that here, 43.0. So my result has a decimal number, even though it is a whole number, it has a .0. So whenever it has a decimal place, Python assumes it's a float and is going to cast it and convert it to a float type. I lose my precision and I lose my speed, but I gain in functionality, I gain any number that I possibly could need. So that's the advantage. So I can do math with addition, subtraction, multiplication, with integers and floats together, but I'm always going to end up with a float. What if I try to do math with two strings? Print, we'll call this string 1, and I want to add to it string 2. Oops, not string 2. Now, traditionally, we add numbers. We don't really add list of characters together. But intuitively, what you think should happen is kind of what happens. It's going to slam the two strings together and make one long string. That's string 1 and string 2 together. You might have seen this on your banking website or any website that you log in. You might see in the upper left-hand corner, it'll like say, welcome, comma, and then we'll do a variable, name equals Jonathan. So I'm going to go ahead and print that out. So you'll see, welcome, Jonathan. You might see that in like upper, and you can access your account and things like that. What it's doing behind the scenes in the actual code, it's doing string addition. It's adding the strings together. So while we don't typically see that in math, it makes sense enough in programming that we allow that action to take place. What we don't allow, let's say age is equal to, I don't know, say 19. I can't add a string, because it starts with quotes and ends with quotes. Name is a variable that references a string. Duck typing, whatever data type is here gets assigned to name. That's the data type it is. So name is also a string. And then age, which is an int. So I can't do this because it doesn't make intuitive sense. So if you actually run this, you'll see I get a type error. I cannot concatenate or combine strings with an int. It's just not intuitive, so we don't allow it. We get an error. Now, if we look at other programming languages, maybe we do allow it, like hello world plus 19 or 10, right? If I run this now in C#, where's my debug? There it is. You'll see it actually, some languages say, you know what? Our intuition says we can make it, we just turn 10 into a string and we convert it to hello world exclamation 10. Python says that's not intuitive, so we're not going to allow that to happen. But just know that's a decision that the language Python chose to make, not a forcing function of the way computers are architected. So just thought I'd throw that out there as a learning point. Okay, so I can add strings together, I can add numbers together, and I keep whatever data type they are initially, right? So I can keep it as integers, I can convert them to floating point numbers. Whatever the data type they are is the data type that they remain. Okay, we're going to add another block here. One thing I want to talk about next is division. So division, if I said, I don't know, we'll say my var1 equals 14, my var2 equals 67. Now I want to say, what is my var1 divided, or we'll do my var2 divided by my var1. The dividing symbol, the two data types going in are integers or floats. Yep, they're integers, right? Because they don't have the decimal place. Watch what happens when I run this statement. I get a floating point number. Division says, hey, it's better to lose precision by doing the math, because if I did it as an integer math, I wouldn't be allowed to have this decimal place, so I would get the value of 4. So it's like, it's better to give you the decimal place and have rounding issues than it is to give you a number that you're not expecting. So it always casts two integers, it's going to convert them into floating point numbers. So if I'll try to get the type, you'll see that it converts it to a float. Even though we had two integers to begin with, our result is going to be a floating point number. And that may or may not be of concern depending on the way our application is written. So there are ways that we can mitigate that, and that's what we're going to talk about next. There's two types of division. There's the regular division, and then there's floor division, where I use two forward slashes. So let's see what that looks like. I'm going to copy this, do a new section of code, and instead of my var1, I'm going to do 2 slashes and see what data types we get. And we get 4. I lose the decimal place on it, but I gain the fact that it's now considered an integer. And this sometimes is useful. You could be like, hey, how many times can I go into, if I had 67, how many times can I divide 67 into 14 with the whole number? And you say, I can do that 4 times. Then I might want to say, okay, well, how many would I have left over if I did that? If I divide 67 into 14 4 times, let's do that math real quick. Let's see how that works. So we're going to say 14 times 4, because we said 67 goes into it 4 times. Let's print that out. And we get 56. Then I would say, okay, I've got this, 56, and I want to say 67 minus this result, and I should get back 11, right? So I can do it 4 times. I can put 67 into 14 4 times, and then I'll have 11 left over. We could do it this way and play around with the numbers and try to figure that out, or we can do it with what's called a modulus operator, and that's what we have here. Modulus gives us the remainder that would be left over after you've divided as many times as you can. So if I run, instead of running this thing, I could run my var2 modulus, which is the parenthesis sign, my var1. And if I did this right, I get the same result of 11. So what's really going on behind the scenes, if I really wanted to see how to do this, we'll add a couple more of these. I could make really complex math in here. I could say my var1 floor division, or my var2 floor division and that's going to give me 4. So then I can say, let's do that times my var2. And that's going to give me, oops, I did not do that right. What is the my var1? Oh, my var1. That's not my var2, my var1. That should give us our 56. And then I can subtract that whole thing from 67. So I could say my var2 minus this whole thing, and I can put the whole thing in parentheses. Right, there we go. And I get my 11. So this statement here is the equivalent of this statement up here. This is much more readable, right? I can read this and say, oh, I kind of understand what's going on. This one here, if I'm looking at it, to be honest with you, it would take me a while to decipher what I'm doing. This is a great example of where I'd want to throw in a comment. Didn't do modulus, we'll just say mod operator, but that is the of this statement, right? So if I change the numbers here, we'll say 17 and we'll say 145, and I run it, I get 9. Let's change the same numbers for here and see if we actually get the same result. And we do. So I could do this statement, or I could do this statement. This statement seems way easier for me to understand and read, and hence it doesn't even require a comment. I know what you're asking. You're asking, well, how often is this useful? Well, it's useful in some ways for writing output to screen. Sometimes we want to use the modulus to only do something so often. It's used a lot in cryptography. I'm sure there's other areas where the modulus operator is useful, but I'll give you a quick demo. Let's do a for loop. We'll say for I in range of 100, and let's go ahead and print the value of I. And it's going to print 100 times, starting at 0, and it's going to go to 99, right? Well, what if this was, I'm pinging a computer every so often. Every 5 minutes, I want to ping a computer to see if it's online, or maybe every 30 seconds. I'm just doing some activity to see if my computer is still on the network. Maybe I don't want to print it out every single time, so I can run a modulus operator. I can say if I modulus, oops, that's not modulus. There, oops. If modulus, and we'll say every, I don't know, we'll say every 7 times through, then I'm going to print. And I'm going to say this is equal to 0. And you'll see that in a second what double equals does, but we'll say, all right, see how that looks. And now what it does is it only prints the variable I every 7th time through my 100 computers that I'm looping through. So you can see if I want to change the modulus to be like every 10 computers, and you'll see it goes 0, 10, 20, 30, up to 90, right? So the modulus can be used if I want to filter my output sometimes. It's used a lot in cryptography, so it does have quite a bit of value in math. So I just wanted you, because you don't typically see it in calculus or algebra kind of expressions, but it does come in handy when we start writing code. Okay, so that is the arithmetic. Oh, I forgot exponential exponent. This is a fun one, right? If I want to take something to a power, like say, hey, 3 to the 3rd power, that's 3 times 3 times 3, which I think 3 times 3 is 9, 9 times 3 is 27, so I can print this out. And you'll see we get 27. So what's 27 times 3? That just means we got to go to the 4th power. That should be, what, 81? There you go. You can also learn your 2's exponents, right? So if I do 2 to the 1, that's 2. What if I do 2 to the 2? 4, obviously, that should be 6. Then we go 8, 16, 32, 128, 256, 512, 1024, 2048. So if we just keep exponential increasing the number 2, we can see the powers of 2. So let's see how that works. Let's do a for loop for I in range of, I don't know, we'll go to 15. We're going to say 2 to the power of I. I the first time through is going to be 0, then it's going to be 1, then it's going to be 2, and it's going to go all the way up to 14. We can see the powers of 2 all the way up to 14. So 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096. 8 gigs is 8192. 16 gigs is 16,384. So if you have 16 gigs of RAM, that's the actual number you have, right? So 16,384 megabytes, 16 gigabytes there. Okay, so that's the arithmetic operations. Let's go and look at, well, let's jump to comparison operators. We'll come back to logical operators. I think it makes more sense to do comparisons because these deal with numbers, these deal with Boolean expressions. So for instance, we can say, I don't know, 5 equals 5. This is not an assignment. Now we're looking at equality. So if I did before, I could say like my var, and I would do an assignment, and I would say it's equal to 5, right? And I would set it to be 1 equal sign. I'm doing an assignment, putting this value into this variable. 2 equal signs is doing a comparison. And let's go ahead and print this result. So this is an assignment. I'm assigning the variable 5 to my var. And then I'm testing, does my var equal 5? And the answer is yes, it does. That's a true statement. What if I said, is my var equal to 5.0? What do we think? Yes. So Python is nice enough to say, hey, this is a floating point number. Let's compare this as if it were a floating point number and do the comparison that way, rather than doing an int comparing to a float. Not all programming languages are that nice. This is a nicety of Python, and one I think is actually helpful for developers. So I can actually compare a float to an integer just fine. What if I did, I don't know, we'll say 4. And I can run that, and you'll see that's a false statement, because 4, I'm testing for equality here, does not equal the value of 5, right? Those are not equal statements, therefore my result is false. Okay, then I could always do this exclamation point equal sign, and what that says, the exclamation is the same thing as saying the word not. So I'm saying my var is not equal to 4. In that case, that is a true statement because 5 does not equal 4. So therefore, I get a true statement. If I said my var is not equal to 5, that is false because it is equal to 5. Therefore, that would be saying something that's false. And I could do something like, is my var, which is 5, greater than 2? And the answer is yes, right? Because I can do single greater than, it's going to compare the results and decide whether or not the variable 5 is greater than 2. In this case, it is. But if I change my var to be 1, then I would get a false, because 1 is not greater than 2. Back to 5, so I don't get confuse myself there. I can do the same thing with less than operator. I can say, hey, is 5 less than 2? And that's false, so therefore I should get a false result. I can do less than or equals, and that's still false. But if it equals 2, now that's a true statement, right? Because 2 is either less than 2 or 2 is equal to 2. And since 2 is equal to 2, we're good, right? Okay, then we have the greater than. Let's put this back to 5. And I can say, is 5 greater than or equal to 2? And the answer is yes. Now that we have the understanding of comparison operators, I'm comparing numbers on one side to numbers on the other side. I can do it with integers, and I can do it with floating point numbers. You saw me do it with a 5.0. I could do it with a 5.125. And I can say, is 5.125 greater than or equal to 5? And the answer is yes, it is. What if I did that? You know, this is a new statement. I haven't tried this before. Let's go outside of script here a little bit. We're going to do our 1/9 technique. actually copy that, and we'll do that 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to say my var now. Let's just print my var so we can see what that looks like. And I see it's 1.000002. What if I said is my bar double equal to the number 1? Now technically it should, right? Because 1/9 added 9 times should be the value of 1. But we see that it actually gives us 1.000002. Is that rounding, and I don't even know the answer to this question, going to be enough to where we can say my var is equal to 1? I don't know. Let's find out. Ah, look at that. It's false. So when I do an equals, it has to be exactly the same. Learn something new every day. All right, is my var greater than or equal to 1? And that answer should be a yes, right? There we go. So that's my example for doing comparison operators. We can take these comparison operators now and combine them. So I could say something like if, we'll say age is greater than 21, and I can use and, I don't know why I did this in parentheses. If statements don't need parentheses. And let's see what else we want to say. Age is greater than 21, and we'll say height is greater than 70 inches. We'll make the person's height 85 inches. I don't know. That's really high, tall. If that's the case, then I can say something like and we'll say 74 inches. Oops. And if you're taller than 74 inches, hey, you should be playing the sport of basketball. I don't know. I'm just throwing something out there. Why does it not like and? Because I did it all capital, and case sensitivity matters, and the variable is called A and D, not capital and. I'm used to other programming languages, sorry. There we go. So that worked just fine, and because age is, I forgot to say what age is, I forgot to define age, we'll say is equal to 25. Now when I run this, it says the person should be playing basketball. What if I did, we'll say the person's actually only 64 inches, 65 inches, and we don't get anything because this statement equates to false. That's because both this has to be true, age greater than 21, and height greater than 74 have to be true. Let's change this to an or statement. Hey, if you're over the age of 21 or you're above 74 inches, go ahead and play basketball. There we go. So or statements, either one of these can be true, or both. So if age is greater than 21, which it is, and height is less than or greater than 74, which it's not, because this statement is true, we execute and play basketball. What if I change myself back to being 85? Both statements are true. I still get to play basketball. Now the fun begins when I can do not, right? I can take this whole thing and just put a not in front of it. So if this is true or this is true, then my statement's true, and then I have this not, which inverts it and makes it a false. So let's see what that looks like. I can add an else statement here. All right. Why did that? Okay, let's see what happened here. So I gotta put these in parentheses so it combines these two together. Okay. What I do with parentheses is I linked age and the or statement together as one thing, and then it takes the inverse of that whole thing. Otherwise, what I was doing without these parentheses, it was taking this not and making this, checking this statement, which is true. So this whole statement here is false. But then it was doing the or and saying, hey, the height is greater than 75, so make this whole statement true. So that's why I had to put a parentheses around it, because I want to do these two statements together first, evaluate these two statements, and then take the inverse of that. So that's the intended statement that we did. And now you can start to see why bugs happen in code, right? Because if I forget to put these parentheses, I run this, it's telling me to play basketball, and that's not what I intended, right? I intended for the age and height to be compared first and then take the inverse of that. But in my testing, say I have my height of the person I'm testing is only 65, then it's going to say, hey, I got to the else statement, and I think my whole statement is accurate. But later somebody comes in and says, nope, I'm actually 85 inches, and I get the statement that I wasn't expecting. So code can get very complex very quickly. That's why I always like to say, play around with the stuff, learn how it works, be curious. Okay, so that is the and the or and the not. So I think that's pretty much what I want to cover for this last module of the day. So hopefully you got something out of this. You're enjoying it. If you do, like I said, like and subscribe to the videos, share it with your friends, and also comment on them so I know what other topics you'd like me to cover. It can be totally anything in the cybersecurity field. I'd like to cover a lot of those topics. So my big takeaway is these statements, comparison operators, mathematical arithmetic operators that we looked at, and the logical operators are going to be used a lot in our flow control. So when we get to if statements, when we get to looping statements, these are going to be the things that are going to help us manipulate the code in such a way that we can do things a set number of times or until a certain condition is met. We can use these statements as a way to dictate how our recipe for cheesecake that we're making here is going to be played out by the interpreter. So when we get to the next lesson, go back to my lesson here, when we talk about flow control, this stuff is going to feed in nicely, and you'll see how all these statements that we've learned today will show us how we can do if statements, else statements, switch statements, and looping. So hope you enjoyed that. I'll see you tomorrow, hopefully, and share and like these videos with your friends.